Welcome back to Principles of Engineering. Today we're talking about series circuits. And before we get going on looking at this particular circuit, let's go through and talk about some of the rules of series circuits. The first rule of series circuits basically just says that the sum of the voltage drops across all of the elements within the circuit have to equal the source voltage. So my source voltage in this circuit is 60 volts right here. And this just says that if I add V1 plus V2 plus V3, that has to equal 60 volts. So my first question here would be, if my voltages are as shown, 10 volts, 30 volts, and an unknown, what would V3 be? So I can apply that and I can say that my V subtotal is equal to V1 plus V2 plus V3. If I substitute my numbers in, what do I get? 10 volts plus 30 volts plus V3. Solving that, what I find then is V3 is equal to 20 volts. Now that's kind of an important idea in a series circuit and will allow you to solve a lot of different scenarios within that circuit. Now the second big idea here is that the sum of the voltage drops, the sum of the resistances equals the total resistance. And all that says is I can represent this circuit with an equivalent resistance, and I'll call that RT. And RT equals to R1 plus R2 plus R3. And that allows me to draw this circuit, this is my poorly drawn battery, as nothing more than a single resistor with a value RT. Now, if I was to tell you that my current through this circuit, I total, had a value, you would be able to see here the third rule, and that is that the total current through the circuit is the same as the current through each element. So that same current, I total, flows through all three elements. And if I call this I1, I2, and I3, I come up with my series circuit current law. So I've got three different rules here. One for voltage, one for resistance, one for current. Now if I told you that I total in this circuit, or I sub t, was equal to 1 amp. So let's write that in. Could I solve now for R1? And I absolutely could. I could use Ohm's law. And I haven't written much for Ohm's law up here yet, so let's go ahead and go through that. Ohm's law basically says that my voltage is equal to my current times my resistance. I can maneuver these around algebraically, and I can also solve for current. I can say my current is equal to my voltage divided by my resistance. And I can also solve for my resistance by saying that that's equal to my voltage divided by my current. These together are known as Ohm's law. So if I know that my total current is 1 amp, I can now say that I've got 1 amp going through a resistor R1 to create 10 volts. So I'm going to use my resistance formula. And here I would say my resistance is equal to 10 volts divided by 1 ampere. That equals to 10 ohms. And that's R1. Similarly, I could go over and I could say R2 is equal to 30 volts divided by 1 amp equals to 30 ohms. And R3 would be 20 volts divided by 1 amp, or 20 ohms. This thus allows me to solve for R total. R total is going to be equal to 10 ohms of R1 plus 30 ohms of R2 plus 20 ohms of R3. Adding all those together, I'm going to get 60 ohms. Now I can check this and I can come back up here and I can basically now say if I was to use this model, I can double check what my current total would be. And if I redrew that model, I'd have 60 volts as my source, going through a 60 ohm resistor, R total, and that would create a current of voltage divided by resistance, V total, R total. That's going to equal to 60 volts divided by 60 ohms, or 1 amp. So now I've used my equivalent circuit to verify what my current was calculated at originally. And I've solved the circuit. Hopefully that clears up a few ideas for series circuits and helps you to solve your problems. If you use one of these steps for each one of your problems, you'll be able to solve it. The first few problems, we start out just using Ohm's law. After that, we'll ask you to look for the sum of the voltages and also to calculate the equivalent resistance. And always remember that the current total is the same throughout the circuit. Thanks for watching.